All right, so the determinant's a weird thing. And what I need to know about it is that the determinant is a function. Okay, so let me draw this the other way. So a determinant's a function. It starts with something. You do this det thing to it, and you get something out. What's the thing you feed into det? Like, what do you determine? What do you apply this thing to? And I say you should find the determinant of what category does that thing have to be? Yeah, it's got to be a matrix, right? Specifically a square one. So this thing takes square matrices. And does what? What does it make? When you take the determinant of a matrix, what do you get?
A single number?
Yeah, you get a number. Cool? So this takes a square matrix, turns it into a number. The interesting thing is what that number means. Okay? So the takeaway for right now is that if a think matrix, right, has determinant of A equals, what's the weirdest number?
73.4.
No.
7.
1 plus 2 5.
1, just 1.
Okay. I'm going to pretend 0 is the. So 0 is kind of a strange number for a lot of reasons. One, it's the one you can't divide by, right? And remember in the 2 by 2 the 2 by 2 matrix trick, you have to divide by the determinant. Find the inverse, right? I don't know how to divide by this, so determinant is 0 implies
There's no inverse.
Perfect. Okay, now the weird thing, right? I just said if the determinant is 0, then A doesn't have an inverse, right? The other way is also true. So if A has an inverse, then its determinant isn't 0. You guys know? And also determinant of A not being 0 implies A inverse exists. You guys see that? So right now, this level, take a determinant. If it's 0, you're not going to find an inverse. If it's not 0, you're good to go. Go try to find one. Cool? Another thought you could have about this that wouldn't be half bad is this thing means smashing. So A smushes something. You guys cool with that? Really what I mean by that is it loses a dimension as a function. Any questions on this? Complaints, issues? You should have one primary complaint about this. I said the determinant was a function, right?
Yeah.
It takes square matrices to numbers. What are square matrices? Yep, they're functions. You guys see that? This is an example of a function that acts on functions. It's a little bit awkward, right? The range of this, or the domain of this thing is all square matrices. Right? That's a bunch of functions.
So the function of functions.
Yeah, exactly. This is a function that takes functions as an input. So,
It gives you a number.
is it weird? Yeah, it's hella weird. Does it work? Yeah. Is it a little bit useful? Yeah, it's a little bit faster for me to find a determinant than it is to try to calculate an inverse. And it gives me a tool for like, oh, if I punch something in the calculator and it doesn't seem to be finding an inverse, like Donald's earlier adventure in trying to flip
I
a
was
matrix?
raising to the -1 instead of pressing the inverse button.
Oh, that totally doesn't work.
Yeah.
That's a good point. Okay, anyway, that wasn't Donald's issue. But this would be a potential issue, right? If you think something has an inverse, you go to type it in the calculator and it gives you some kind of, hey, what the heck, error. You might hit the determinant button, put the matrix in, and just see if it has determinant 0. Right? If it has determinant 0, you might go hunting for your typo or rethink about your problem. Does that make sense? Okay.
When you mean smashing happens, you mean taking A and doing almost anything with it, then smashing happens?
I mean that A as a function, so A takes some, if it's square, right? It takes some n vectors into other n vectors. And what I mean is that this is actually into, like, for example, here's R2, right? This is the usual xy plane.
Yes.
So if I took all that xy plane and put it into the xy plane, by just smashing everything onto the x-axis. Right, so take this whole plane and just smush it, stick it in there. That's the matrix. So this matrix is 1, 0, 0, 0. Right, if I apply that to a vector xy, I get just the x coordinate and the y coordinate turns to 0. Right, so that's me just going. And that's really what I mean by smashing. I mean it collapsed the dimension. Does that kind of make sense? It's okay if that's a little bit over the top for you guys. Cool. Thoughts? Questions?
Just a note.
Sure.
3 Blue, 1 Brown has a great video that actually gives the visual interpretation of determinants as what it actually shows.
Yeah, sure. So determinants are really, so what this number means is some kind of a distortion of area. And there's a number of good videos for how that distortion looks. You can actually fiddle with it a little bit if you draw a unit square in the starting place and then apply the matrix to it. You can see how the determinant smushed that area out. Cool? 0, right, of course, means that it actually lost area. It lost the dimension.